Many elements in the periodic table have atoms with incomplete valence shells. Some have only a few electrons in these shells, while others are a few electrons short of the preferred octet state. For example, alkali and alkaline earth metal atoms, some transition earth and other metal atoms have only 1 or 2 electrons in their valence shells. They can easily lose these electrons to become positively charged ions called cations. On the other hand, halogens and some other nonmetals can gain 1 or 2 electrons, acquiring a negative charge, and form negatively charged ions called anions. Ionic bonds are formed between atoms with sharply different electronegativities. So the electrostatic interaction between cations like sodium and anions like chloride form these ionic bonds. But do proteins and nucleic acids have anions and cations? Let's look at the structure of an amino acid aspartate. The backbone amino and carboxyl groups, as well as the side chain carboxyl groups, are shown protonated but neutral here. At the physiological pH, the side chain carboxyl is deprotonated and negatively charged. Thus, at neutral or physiological pH, aspartate and glutamate have side chains that are deprotonated and negatively charged, while lysine, arginine, and histidine have protonated side chains and are positively charged. So in proteins, electrostatic interactions between positively and negatively charged amino acid side chains can form ionic bonds. Ionic bonds or salt bridges are often found stabilizing the surface of soluble proteins in exposed loops and also in protein nucleic acid interactions. To find ionic bonds in protein and nucleic acid structures, examine the neighborhood of amino acids with charged side chains like lysine, arginine, aspartate, glutamate, or phosphate groups such as in the phosphodiester backbone of nucleic acid. Look for oppositely charged groups within around 4 angstroms of each other to find these non-directional ionic bonds. In this structure, which of these 5 charged amino acids form ionic bonds? 4 of these amino acids form a network of ionic bonds, while the 5th one is too far away.